Okay, so today we are going to discuss the topic further coordinate systems. Okay, so first we'll write the topic ellipses. Okay, so I think previously in F1 you have discussed these coordinate systems under the shape parabola. Do you remember y square equals 4ax? So likewise, now what's going to happen in the F3 book is we will be continuing with that. So we are going to go into a few more special cases, right? So the first case we are going to discuss under F3 is the first case is the ellipse. Okay. So in further pure one, yeah, we learned about the rectangular hyperbola. Yeah, we learned about actually the parabola and the rectangular hyperbola. So now under these phonics sections, we are going to learn about this new section called ellipses. So shall we write down the equation of the ellipse? The first thing is the standard ellipse has the Cartesian equation x square over a square plus y square over b square equals 1. Now here a and b are both constant. And can you see how the ellipse looks? So you can see it kind of has like this oval shape, and you can see these cutting points. You can get these x cutting points when you set y to 0, and you can get the y cutting points when you set x to 0. You can get those things easily. Let's quickly write down. So these are things you need to know. The standard ellipse has the Cartesian equation x square plus x square over a square plus y square over b square equals 1. And also you must know another important thing is the standard ellipse has the parametric equation. X equal a cos t and y equal b sin t. So these are the two parametric equations. So you must know the Cartesian equation as well as the parametric equation for the ellipse. Okay, so first you must note it now. Okay, so now what we'll do is next thing we are going to do is we will learn how to sketch the ellipse. Okay, so look at exercise 2A question number 1. Sketch the following ellipses showing clearly the curves across the coordinate axis. Okay, so the first one, part A, Roman number 1. Okay, so x square plus y square, x square plus 4y square, right? Equals 16. Okay, so the first thing is you need to make it into a ellipse format. Can you remember the ellipse format now? The ellipse format was x square over a square plus y square over b square equals 1. It must be equal to what? It must be equal to 1. You see, and also you must have the plus sign in the middle, like all this x square should be there, y square should be there. So all those things are must be met, all these conditions. Okay. So what I'll do is I'll take this equation, and since I want to make it equal to 1, I'll divide the entire equation by what? 16. We'll divide the entire equation by 16. You can see then in that case we get we need to make this side 1. So I end up getting here x square over 16 plus y square over 4 equals to 1. So I think you can see your a square and b square values here, right? Okay, so basically to sketch the ellipse, you cut the x-axis on the standard ellipse that we drew earlier. This was how the ellipse looked, right? The x-axis cutting points were plus a and minus a. The y-axis cutting points were plus b and minus b. I mean, you could simply make x0 get the y cutting points, y0 get the x cutting points. It works. Okay, so it's easier to remember. Okay. Okay, then what are the x cutting points here? This is 16 is a square. Remember, 16 is a square. This 4 is b square. Yeah, so which means a square 16 means a is 4 and minus 4. B square is 4 means b is 2 and minus 2. So simply draw an ellipse which passes through all these points. Okay, so it's a rough shape that I have drawn. So something try to draw it a little bit better. Okay, let's do another one. To Roman number 3. Okay, so we'll move on to part 3, x square plus 9y square equals 25. So obviously you can understand that I need to divide everyone with 25, right? So when I divide everyone with 25, I end up getting here x square over 25 plus 9y square over 25. Do you see that we have a little bit of a problem here, equal 1. Now, you know, in the standard ellipse equation, do you have any number or do you have anything indirectly in front of y square? No, so I can't have 9y square here. So what should I do here? What should I do here? I cannot have this 9y square here. So did you draw the graph by using the 9y square? Yes. So what we do is we take that 9 down as a denominator. So this is y square over 25 over 9 equal to 1. Do you see it? So you need to have your y square clearly here alone. Okay, so this is the equation x square over 25 plus y square over 25 over 9 equal 1. So basically your a square is 25. So a square is 25 means a is 5, right? B square is 25 over 9, which means b is 5 over 3. You can easily get it. So then you have your a and b values. Simply you can sketch the graph, right? So you can sketch the graph. The cutting points are a is 5 and minus 5. Y cutting points are plus 5 over 3 and minus 5 over 3. Is that okay? Then in the next one, okay, in Roman number, question number 2, Roman number 1, sketch the ellipses with the following parametric equations. Roman number 1, x equals 2 cos theta and y equals to 3 sin theta. Now, how do we do this one? Okay, y'all know that now I gave you all the Cartesian, the parametric equations, right? What were the parametric equations of an ellipse? X equal a cos theta and y equals to b sin. I think you can like see literally the AB values here. Like directly you can see, or else you could like think cos theta varies between 0 to 1 to minus 1, and see your x values are going to vary between minus 1 and minus 2 and plus 2. If you get what I'm saying, cos theta varies between minus 1 to plus 1. So x values vary between minus 2 to plus 2. And sin theta also varies between minus 1 to plus 1. So your y values vary from minus 3 to plus 3 to minus 3. So basically, you get an ellipse. Okay, so this is the ellipse. Okay, try to make it look better. Okay, then let's move to the next one. Roman number 4. That's also easy, right? And they want find the Cartesian equation for the ellipse as well, right? Before we move to part 4, shall we write the Cartesian equation? What's the Cartesian equation? X square over a square, which means a is 2, a square is 4 plus y square over b square. B is 3, b square is 9 equals 1. So this is the Cartesian equation. Similarly, do the same thing for this one. X equals 4 cos theta, y equals 3 sin theta. So what do we get here? Write the AB values. Okay, so then the next thing we do here is in part 4, x equals 4 cos theta, y equals 3 sin theta. So A value is 4 and B value is 3, right? So when you draw your ellipse, A values are 4 and minus 4, B values are 3 and minus 3. Is that okay? Okay, and then the next thing we need to do is we need to write the Cartesian equation of the ellipse. So let's write the Cartesian equation. X square over a square is 16 plus y square over b square is 9 equals 1. Right? Is that okay? So these are the so this is a brief explanation of like how the ellipses move and where they cut the x-axis and y-axis. Okay. Okay, so we'll write the next topic. We'll discuss about the next topic, hyperbolas. Okay, so now we are going to move into a new section in the new, we can discuss another new part in the conic section. So that is called hyperbola. So hyperbola, you have discussed a certain type of hyperbola in F1. In F1, you can remember xy equals c square. This one you have discussed. We name it as a rectangular hyperbola. Okay, so this has been done in F1. Okay, so now the standard hyperbola has now, of course, we are not going to talk about the rectangular hyperbola here. Can you see this hyperbola that they have drawn, and can you tell me what's the major difference between these two hyperbolas? This one has a special name, rectangular hyperbola, while this one is just named hyperbola. What's the difference in between these two? Can you see the difference now? This is this is specially named rectangular hyperbola, while this is named just hyperbola. It's the look of the asymptotes. If you see in the rectangular hyperbola, your asymptotes are what? Perpendicular to each other. Yeah, asymptotes make a 90-degree with each other. While in the normal hyperbola, the asymptotes, they don't make a perpendicular. They just cross like this. Can you see? So anyway, in F1, we discussed about the rectangular hyperbola. So now we are going to talk about the standard hyperbola, where the two asymptotes are not, they might not be perpendicular to each other, or they look like this. Can you see? So standard hyperbola has Cartesian equation x square over a square. Can you see the difference now? Minus y square over b square equal 1. So that is the difference between the hyperbola and the ellipse. The ellipse had a plus mark, the hyperbola has a minus sign. And also there are a few extra things in the hyperbola. You can see if you if you try to find the place where you cut x-axis, you can make y0, right? So when you make y0, I didn't do this in the previous one. It was like, this was pretty obvious here. Y is 0 over b square equal 1. Do you see here x square over a square? This guy is completely a 0. Do you agree? This part is 0 over b square is 0 equals to 1, right? Which means I get x square equal a square, x equals to plus or minus a, which is what I have over here, plus a minus a, 2x cutting points. But when you, now I'm curious to see what happens whether it cuts the y-axis or not. So because according to the diagram, you can see it doesn't cut the y-axis. So what happens when you cut, let's try to find the place where you cut actually the y-axis. So when you cut y-axis, what happens? X is 0, right? So when you make x 0, what's going to happen here? 0 over a square minus y square over b square equals 1. So this guy is totally 0. This is what? This is just y square over b square? No, minus y square over b square equal 1, which means y square equals minus b square. So I get y equals square root of minus b square. So is it possible to get the root of, I mean, we can get roots, but we don't get real roots. We get imaginary roots. So then in real root, I mean, in the sense it doesn't cut. Basically, it doesn't cut. Okay. So there are no real roots, no real solutions. Okay, so basically it means it doesn't cut. So you can see how this diagram makes sense, right? And then the two more important things in this diagram are the asymptotes. So they have named the two asymptotes as y equal b over ax, the one with the positive gradient, and the other one is y equal minus b over ax. That's the one with the negative gradient. Okay, so make a note of these things. These are the special things you need to know in this particular lesson. This equation, and you need to know the equations of the asymptotes, y equal plus or minus b over ax, and also you need to know the parametric equations. So they are given in the next page. So first write this down, then I will give you all the parametric equations. Okay, then the next thing I want you all to do is write the equation for the hyperbolic equations. Write the hyperbolic equations for the write the parametric equations. Write the parametric equations for the hyperbola. Write down these two equations. So they have given you two sets of parametric equations. The standard hyperbola has parametric equations about plus or minus a cos t and y equal b sin t, and the other one is x equal a sec theta, y equal b tan theta. So write this down. So there are two sets of equation. The one we most widely use is this one, the second one. Okay, because in the first one you can see there's a plus or minus possibility, right? So both are okay, but mainly I have seen them going with this. Even the other one is fine. Okay, so these are what the parametric equations for the standard hyperbola. And once again, you know what a and b represent, the same thing as in the participle. Okay. Okay, so let's go for the next one. Sketch the following hyperbolas showing clearly the intersections with the x-axis and the equations of the asymptote. So first thing is this. First you need to fix this given equation into the standard hyperbola equation. So let's fix that x square minus 4y square equals 16. Can someone remind me what is the standard hyperbola equation? Remind me. X square over a square minus y square over b square equals to 1. So these are the important things. The minus mark in the middle is there and equals to 1. It must be equal to 1. Do you hear me? The final thing must be equal to 1. You cannot have any other number here. Okay, then inside in the middle of these two, you must have the minus sign. And also your x square, the a is below the x square, the b is also below the y. Do you see? So it needs to follow this format strictly to be a rectangular, to be a hyperbola. Okay, right. So now according to this equation, you can see it doesn't follow this format. So I have 16 here. Basically what I'll do is I'll divide the whole equation by 16 because I want to make it look like this top one. Okay, I want to make it equal to 1. I end up getting x square over 16 minus 4y square over 16 gives me y square over 4, right? Equals 16 over 16 is 1. So you can see clearly now what are your a square values and b square values. So basically you remember how the rectangular, the hyperbola works. So uh, according to the image, you remember there are two asymptotes, right? So before I start drawing, shall we find the two asymptotes? What's the equation of the two asymptotes? Y equals plus or minus b over ax. So these are things that you need to remember. Okay, y equals plus or minus b over ax. So let's input the values. Y equals plus or minus b is, yeah, b square is 4, b is 2, a square is 16, a is 4, which means basically y equals plus or minus half x. Is that okay? Y equals plus or minus half x, and then those are your two asymptotes. So you can sketch the two asymptotes. Half x is a line that is going through the going through 0, 0. And then you can mark the, and you know this cutting point here is what? The two cutting points are a and minus a, isn't it? You remember? Yes, I showed you that the y-axis doesn't cut. So then the a values are 4 and minus 4. Is that correct? Yeah. And so you draw your graph in some manner like this. So this is it. So this is the hyperbola graph. Can you see? Okay, similarly, can you all try to draw the part C1 also? Asymptotes name correctly. You must name your asymptotes. Yes, please name the asymptotes. The first asymptote is the positive gradient one. So you can identify positive gradient one is this one. One I'm marking right now, y equal plus half x. The negative gradient one will be y equal minus half x. Make sure you name your asymptotes. You must name them. And you must name each place where the graph cuts the x-axis along with its asymptote. Then only you get the complete sketch. Okay, so this is the complete sketch of the standard hyperbola. Okay, so now start sketching part C. So part C. In part C, how do we get the a square, a value and the b value? X square over 8 minus y square over 2 equal 1, right? So here I think you can see we have the equal 1. So I don't need to divide it with anyone else, right? However, we can see here this time our a square value is, so basically the a square value is 8, which gives me the a value is root 8, which means 2 root 2. And b square value is 2, which means b is root 2. Do you see? These are the a and b values. So we put the plus minus. So anyway, I just want the value, the magnitude of a and b. So basically, with the magnitude of a and b, I can now sketch my hyperbola, right? So when I sketch the hyperbola, the two asymptotes are y equal b over ax. Is that correct? Y equal b over ax plus or minus the asymptotes. Shall I write it over here? Asymptotes are y equal plus or minus b over ax, which gives me plus or minus b is root 2, a is 2 root 2. And then make sure here you can cut off the root 2 to root 2. So you end up getting here y equal plus or minus half x. These are your two asymptotes. So name them. So the first asymptote, the positive gradient one is the half x. The negative gradient one should be the y equal minus half x. Okay, and then the graph needs to go like this, right? And then the cutting points are a and plus a and minus a, right? 2 root 2 and minus 2 root 2. Can you see? So this is the full hyperbola graph. And are they asking for the cards? So we have written the cards in equations. Okay, so then let's go for the next one, question number 2. Okay, in question number 2 also they wanted to sketch the hyperbola with the following parametric equations, give the equations with the asymptotes and show the points of intersections with the x-axis. So in question number 2 part A, to do this also I have given you the equations for the parametric, I have given you the parametric equations, the format, right? So what's the format? The format was x equal a sine theta, right? X equal a sec theta and y equal b tan theta. Is that correct? So basically I have the a and b values. So when I have the a and b values, I can write my asymptotes. So this gives me the a value. A value is 2. B value is 3, which gives me my asymptote equations are y equal plus or minus b over ax, which gives me y equal plus or minus 3 over 2x. Right? So these are the two parametric equations. So then I get here a is minus 2 and plus 2. Okay. And so this is the equation y equal plus 3 over 2x. And this one is y equal minus 3 over 2x. Okay, so this is the equation. This is the sketch of the hyperbola. And you also need to get the the Cartesian equation. So the Cartesian equation of the hyperbola will be x square over a square will be 2 square, minus, because it's a hyperbola, it should be minus y square over b square equals 1. So basically it's going to be x square over 4 minus y square over 9 equals 1. Is this clear? Okay, so it's quite simple. Then the next one, following the same format, let's do Roman number 2. So this is another format they have given for the parametric equation, right? So plus or minus a cos t and b sin t, right? This was what they had given, yes. So once again, it's quite simple. All you need to do is just pick up the a and b values, right? So pick up your a, b values and input them into the equation, okay? Then I end up getting here x equals Roman number 2. X equals plus or minus 4 cos t, y equals 3 sin t. So this gives me the a value as 4 and the b value as 3. So let's write the asymptotes. The asymptotes are going to be y equals b over ax, right? So y equal b is 3, a is 4, 3 over 4x plus or minus. And then let's draw the graph. So when we draw the graph, this is going to be, yeah, y equal is the negative 3 over 4x. This guy will be the positive 3 over 4x, right? That two asymptotes, and then you draw the hyperbolas. And then the cutting points are at minus a and plus a, minus a and plus a. So this is how the sketch looks like, the rectangle, the hyperbola. This is the standard hyperbola equation. Okay. Okay, so the next section that we are going to discuss in this lesson is eccentricity. Okay, so what is eccentricity and why is it important? Okay, so they are telling you that this term eccentricity is what helps us to separate, to get the difference between actually the ellipse, a hyperbola. I mean, mainly how we can differ. I mean, how we can separate them. What are the differences? I mean, how it's defined. Basically, the eccentricity shows how these maybe equations are defined. Okay, so we can define the ellipse and hyperbola in terms of their focus directrix properties. Now, I think you remember this word focus directrix. You used in F1 in parabola. Do you remember in the parabola equation in F1? The equation you learned was y square equal 4ax. Do you remember something like that? In the parabola equation, y square, just to remind you, this is F1, the lesson parabola, right? And the equation you learned was y square equal 4ax. So when you draw the parabola, how did it look like? The parabola came like this, right? Can you see? Can you remember? It turned from the 0 point. Okay, it turned on the 0 point, and then there were two special things here. One is the focus. The focus was at a comma 0. This is the focus. And then there was another important thing called the directrix. Okay, x equal minus a, or we say x plus a equals 0, or we say x equal minus a. Okay, so this is the directrix. Do you remember this? Okay, then the next thing is there was a special property about the parabola, if you remember. There was a very special property about the parabola. From at any point, the distance from any point to the focus, let's say this is the point P, this distance to the focus, and if you take the not just any distance, the perpendicular distance. So my diagram is like not that great. Okay, the perpendicular distance between these. So if I say this is x, xp and ps are equal at any point. Okay, my diagram doesn't look that great. I need to draw my parabola a little bit wider. Okay, to make it look more realistic. However, the rule is, I mean, the parabola is defined. The parabola is defined in such a way so that at any point, if you take the distance from that point to the focus and the perpendicular distance to the directrix, it's always equal. Like that's the definition. Do you get me? So this is how the parabola has been drawn. How the shape continues to go back. Do you get it? Always the distance from the point, any point, from basically any point to the focus must be equal to the perpendicular distance from that point to its own directrix. Okay, so now likewise, so with this focus and directrix, we are also capable of defining a ellipse and a hyperbola. Now earlier we just discussed only the cutting points and the asymptotes, right? We are not going to any further things, but now we are going to go much deeper into the ellipses and the hyperbolas. Okay, so we are going to discuss them. First, we are going to introduce you the directrix and the focus of these two shapes. Okay, so the first one is, let's write down. So they have given here for all points P on a conic section, the ratio of the distance P from a fixed point called the focus. Okay, and a fixed straight line called the directrix. Do you remember? Now I just now gave you the I kind of reminded you about the focus and the directrix, right? Okay, so the distance from the fixed point focus to the curve, and from that point to the fixed straight line called the directrix is constant. This ratio E is known as the eccentricity of the curve. Can you see what is eccentricity? Eccentricity is the ratio between the distance of the point on your curve to the focus and the perpendicular distance from that point to the directrix. Now you remember in the parabola, these two distances were what? Were equal, which means ratio becomes what? Ratio becomes 1. Because ratio, maybe take it's 1-to-1 ratio because it's equal. Basically, when you divide, you get 1. So basically, that means what? In a parabola, eccentricity is 1, equal 1 in a parabola. Okay. So can you see for all points P on the curve, the ratio PS over PM. Do you see? First we measure the distance from the point on the curve to the focus. Then we measure the distance from the point on the curve to the directrix. So PS on top, PM at the bottom. Okay. So PS over PM equal E is a constant. So this is going to be a constant for, let's say if you take the ellipse, the PS over PM ratio is a constant for the ellipse. It's one value. Okay, if you take the hyperbola, PS over PM is a different constant for the hyperbola. For the entire hyperbola, you have that value constant throughout every point on that curve. The PS over PM ratio is constant for every single point on the curve. So you get what I'm trying to say. So this is called E and it is constant. Okay, so then they say here for E values between 0 and 1, the point P describes an ellipse. If E equals to 1, the point P describes a parabola. This is exactly what I was talking to you a moment ago. When these two guys are equal, ratio is 1, E is 1. Then it describes a parabola. If E is bigger than 1, the point P describes a hyperbola. So these are the rules. These are the rules. So first of all, you need to clearly identify what is this eccentricity. Do you get what's eccentricity? Eccentricity is that constant ratio between PS and PM. Okay, it's not always equal. No? It's only equal in parabola. Okay, yeah, basically when you draw your ellipse or whatever, the distance from the distance from any point to the focus and the distance from that point to the directrix will be equal. Okay, so the first thing you do is this: make a quick sketch of it, make a quick note of it, write it down, because this is the first you define what is the eccentricity and write down these three equations. Okay, so now once we're done with the eccentricity part, okay, so we defined how the eccentricity works for ellipse, parabola, and hyperbola, isn't it? So that's what we discussed, and now what we are going to do is we are going to prove an important equation regarding eccentricity. We are going to prove an important relationship. Okay, so can you all write this down? Actually this example, it's really important. Let's write down. Show that for E values between 0 to 1, the ellipse with focus AE comma 0 and directrix x equals A over E has equation x square over A square plus y square over B square equal 1. Actually, even though this is an example in this book, this example is actually important for you to identify an important relationship. So this example is something that I always choose to teach every batch. Okay. So write down this question and then let's work on this proof. There's something, a really important relationship that we need to prove here. Okay, so write this down. First, write down the question clearly. Okay, so now they have said here, let P be the point with coordinates x comma y. So basically P is a point on your ellipse. We are discussing about the ellipse. Okay, so in the ellipse, you need to realize your E values are what? Between 0 and 1. Now they have told you the focus of the ellipse is at AE and the directrix equation is A over E. So when you compare for E values between 0 and 1, is A multiplied by E larger or A divided by E larger? Which one is larger? Imagine yourself take a number between 0 and 1. Think it's 0.5. So is it A into 0.5? Is that the bigger one or A divided by 0.5? Which one is bigger? A divided by 0.5 actually becomes 2A. A divided by 0.5, A divided by half, it becomes actually 2A. While this one, A into half is half A. So A over E is bigger, which means the directrix is located after the focus. Can you see? A over E, the directrix line is after, the focus is coming first. Directrix comes after, which means like your ellipse goes in this manner. Like your ellipse goes like this. I mean, the focus is inside the ellipse and the directrix is outside the ellipse. Can you see? Anyway, in a shape, the focus always comes inside the shape. Like you saw in the parabola, directrix always comes outside the shape. It doesn't touch inside. Otherwise, we can't take the perpendicular distance from the point to the directrix. Directrix always comes outside the shape. Focus always comes inside the shape. That's the rule. Okay, so you can see it here. So basically, AE, you can see your focus comes inside. It occurs first here because AE is smaller. A over E will definitely be larger for these set of E values. Do you agree? Okay, so now what we are going to do is, you know that our eccentricity is, okay, our eccentricity equation is defined for what? E equals to what? E equals to PS over PM. Am I correct? Yeah. E equals PSO PM from the point to the focus and from the point to the directrix. Okay, so what I want to do is this. First, I want you to individually get me the equation or the distance from P to S and P to M. Okay, how do I get the distance PS? So what is PS? PS is, now you know here P is a random point on our ellipse, right? So let's say the P point is X comma Y. Can you see they have taken P as X comma Y? Okay. So then let's take, how do we get the distance between 2 points? The difference, and I mean x1 minus x2 square plus y1 minus y2 square, and you square root it, right? Can you remember? Okay, so let's get the PS distance. So you can see the P coordinate x comma y, S coordinate is AE comma 0, right? Okay, then let's get it x minus x1 minus x2. So x minus AE square plus the other one is y minus 0 square. Square root, or I could say this is basically PS square. So PS square, if I write it again, PS square is x minus AE square plus basically this is y square. Okay, now do the same thing for PM. Get me the PM distance. I think you can see PM is a horizontal distance. Like you can do we have a difference in between the y coordinates of P and M? Yeah, I mean the basically they are the y coordinates of P and y coordinates of M are the same. So if I go y1 minus y2, you can see there's no y difference. You only have the x difference. So only the x difference is there. Directly the distance from P to M is what?
Minus B.
Yeah, so tell me the x coordinate of M is A over E. A over E minus x. Directly that, right? I don't need to consider y, and I don't even need to put a square here because the distance is horizontal. If it's a horizontal or vertical distance, you can directly take it. Only if it's a slant distance, you need to use this Pythagoras theorem. Okay, so these ones we can take directly. Okay, now what I'll do is let's use it to this equation. However, you can see I have here PS square, right? So what I'll do is I'll make this PM square. Let's make it PM square equal A over E minus X whole thing square. Okay. Now let's input our equation. Our equation also E equal PS over PM. We will square it. So I end up getting what? E square equal PS square over PM square. Take PM square to the other side. So I get here PM square multiplied by E equals PS square. Is that okay? Okay, now let's substitute these values, and we need to we have to get this, show that, right? What are we supposed to do? They are asking you show that for E between 0 to 1, the ellipse with this focus and this directrix has this equation. Basically, this is the show that you need to get. Are you guys with me? We need to work towards this. This is our end goal. We need to get this, okay? Shall we try to get that? Okay, so let's work on this. PM square is A over E minus x holding square into E square equal PS square was x minus AE square plus. Okay, let's work on this. What I'll do is I'll take the common denominator inside here. We can't cut off all the squares because there's a plus mark here. You can't square root everything because there's a plus mark in the middle. When there's a plus mark in the middle, you cannot square root everything. Let's first get the common denominator. This is x a minus ex or xe over e square. I'll open all the brackets at once. So basically, this is a minus ex square over e square, right? There's no ax here. Into e square. This is x minus ae square plus y square. So who cancels off? E square. This e square will cancel out. This e square will cancel out. Okay, then let's open the brackets, right? So let's open the brackets. We all can immediately open brackets. A square. Then you get here minus, because in the middle there's a minus mark. I'm going to open the square bracket immediately. Okay, you know how it opens, right? Squaring the two guys and then double the two values in these two. Okay, so this is minus 2 times AEX. Agreed? And the last one is plus E square X square equals, on the other side I get X square again minus 2AEX plus A square E square, and then you get plus Y square. Do you see? I open the bracket immediately, just square, I mean a plus b whole thing square is a square plus 2ab plus b square. That's simple rule. Or else you could write the bracket twice and open it. Okay, now what we'll do is, I think we can see things that cancel off. Minus 2AEX, minus 2AEX on both sides. When I bring it here as a plus, it cancels out. You agree with me? Okay, then what else can we do? A square plus E square X square. So we need to bring the terms to one side. Bring people together. Right, so we need to get the equation x square over a square plus y square over b square equals 1, right? That's what we need to do. Basically, I have to rearrange this equation to get something like that, isn't it? Okay. Okay, so now it's just a matter of rearrange this equation. Okay, so what I'll do is I'll take the x square terms to one side, and I'll bring the constant terms. Can you see? A square, E square, I'll bring it to this side. Okay. So basically bringing the constant terms to one side. So it becomes x square minus E square X square plus Y square. Is this okay? Can you see I have rearranged? Now I'll take the common thing out here. A square, when I take it becomes A square 1 minus E square. This one when I take out x square 1 minus E square plus Y square. You see? And the thing is, I strategically chose to bring these guys here. I mean, basically the plus y square is also here. Yeah, I need to make sure my x square and the plus y square should be in one side. Okay. So now what I need to do is I need to get the equation, the show that had x square over a square plus y square over b square equals to what? Equals to 1. Do you see I have x square in one place? Can you see I have y square in one place? So I need to make this side equal to what? I have to make this equal to 1. The Cartesian equation of a ellipse is x square over a square plus y square over b square equals 1. So to make it equal to 1, what do you think I should do? Divide everyone with a square 1 minus e square. Divide the whole equation. A square 1 minus e square. So this gives me 1 equal x square over a square plus y square over a square 1 minus e square. Can you see? And now what happens? And you know you're supposed to have here what? It's supposed to be y square over b, right? B square. X square over a square plus y square b square. So you can basically see what b square represents. Can you see? So this is supposed to be the b square value, right? Right. So this tells us the relationship between b, a, and e. So this tells us what? B square in an ellipse, the b square value is equal to what? A square 1 minus e square. And this is an important, one of the most important relationships in this lesson. Remember, this is the relationship between a, b, and e in an ellipse. In an ellipse, the value b square is equal to a square times 1 minus e square. So this is the proof. Okay. Okay, so based on everything that we have found right now, okay, so we have a lot of information we need to mark. So this is the full diagram, the full thing for the ellipse. Can you see? So this is your ellipse, and in addition to the two cutting points a minus a and b minus b, we now have what? We now have something called a focus, right? So your focus AE, and can you see an ellipse has two focus for C, right? Because you are having the not just one. There are, you have two. Okay, so AE and minus AE, and you have two directrices as well. Okay, do you see? So x equal AE and x equal minus AOV. So you have two for C and you have two directrices. Okay, so can you see? Finally, they have given you find ellipse with the equation x square over a square plus y square over b square equals 1. And can you see at this extra condition they have given you? There's an extra condition. And what? A is greater than B. So when A is bigger than B, we say the x-axis is the major axis. Now there is something like that also in the ellipse, which means you must look into which axis, which one is the major axis. If the x values are large, if the x cutting points are larger than the y cutting points, or basically if the A values are bigger than B, then the x-axis is the major axis. And then all these equations, the eccentricity is, E is between 0 and 1 is given by b square equal a square 1 minus e square. This is the equation we just now proved, isn't it? And then the forces are at plus or minus a comma 0. And then the directrices are at x equal plus or minus a over e. Is that okay? So all of these equations are correct when what? When the when your x-axis is the major axis. Yeah, the thing is this, whatever your major axis is, your directrices and forces will be on the major axis. Which means what? In an event, when the y-axis becomes the major axis, your forces and directrices will be on the vertical, on the y-axis. So we'll draw that diagram after this. Can you all first sketch this diagram? This is for what? This is for A greater than B. This particular diagram is only correct for A greater than B. For A, you write the topic when A is greater than B and you sketch this ellipse. So you show your forces, you show your directrices, and you write down all these equations. Okay, write down all these equations. All of these are when A is greater than B. I will give you a separate diagram that you need to consider when what? When A is less than. Okay, so first let's make a note of this and let's write this down. This is the normal one that we normally deal with. Okay, so now let's look what happens when what? When y-axis is the major axis. So when does y-axis become the major axis? Y-axis becomes the major axis for B greater than A. When your B is bigger than A, your y-axis becomes the major axis. Let's draw that. Yeah, the shape will shift, right? So there will be a slight shift in the shape. So basically you have a shape. That roughly looks like this. I'm restyling it. Huh? B minus B, it was not there in the shapes. Okay, so this is what you have, right? This is how it looks when B is greater than. But now, look, there are some differences, meaning your S and the two 4C. Your 4C will now be on which axis? Your 4C will now be on the y-axis. So previously your 4C was AE, right? It was AE. Do you see? Plus or minus AE. So now when it's on the y-axis, your 4C will be at what? Now if the earlier one is on, it will be BE. Because the earlier one was on the x-axis, it was AE. So your 4C, you can write down. Your 4C coordinates are x is 0, comma, plus or minus BE. Okay, so 4C is plus or minus BE and your directrices. Now, what was the directrices in the when you were on the x-axis? X equal A over E. So now, be more specific. Is it x equal B? That's still not y equals B over E, because now it's on the, it's a horizontal directrix. It's not vertical, right? So now your directrices look like this. So y equals to B over E, and the other directrix is y equals to minus B over E. So these are the two directrices. And One more important thing, you must write down the eccentricity equation as well. Directrices are y equal plus or minus p over e. And then the eccentricity equation, how will it be? Earlier equation was b square equal a square 1 minus e square, right? In the earlier set. So now you can see AB actually switches. The A role is taken on by B role is taken on by A now. Because when y-axis is the major, do you see the x asymptote became y asymptote are now x. The directrices, they have all changed. The coordinates also, A used to be the major here, now it's B. So basically, it's the same thing here in eccentricity. Also, the roles of A and B will switch. Earlier one, you had B square equal A square 1 minus E square, right? So now you will have what? The eccentricity equation will be
B square 1 minus E square.
A square equal B square 1 minus E square. So it is absolutely essential that before you start the ellipse question, it's really important. It's mandatory that you check whether the relationship between the A and B values. You get me? You must check whether your A value is greater than B or whether your B value is greater than A. So it's mandatory you check that, because before you even start the question or before you use any equation, because you can see the 4C directrices and the eccentricity equation, you use everything changes according to the major axis. Okay, everything changes according to the major axis. So you need to remember this. Actually, if you check your formula book, in the formula book, they have given you the directrices, the 4C and they have given you the eccentricity equation for the major, when x is the major axis. In your book, you will have in the F3 section, you will have a formula, the table drawn and given. So when you check the table, you will see, check the table and you will see that they have only given the equations when what? When A is greater than B. Make a note of that in your formula book as well, so that you know that these equations are given only for A greater than B. So you must know if B is greater than A, you need to switch all those. Okay, so make a small note of it in your formula book as well, so that you can use it respectively in each case. So find the eccentricity of the following ellipses. Part A, x square over 9 plus y square over 5 equals 1. First thing is check the a square, b square value. So here a square is 9, b square is 5, right? What do you notice? Is a greater than b or b greater than a? Here it is a greater than b, which means we will have the x-axis as the major axis, which means for eccentricity we will use which equation? B square equal a square 1 minus e square. We have to use the correct equation. Okay. So b square is 5, a square is 9 into 1 minus e square. I end up getting here 5 over 9 equal 1 minus e square equal 1 minus 5 over 9 is 4 over 9. So E will be, E is between 0, 1. So I don't need to put plus or minus here. E is 2 over 3. We don't need plus or minus because we clearly know find ellipse E is between 0 and 1. We clearly know that. Okay. In part C, they have told x square over 4 plus y square over 8 equals 1. So which means what here? A square is 4, y square is 8. What does it tell you? Sorry, not y square, b square. What does it tell you? A square, I mean, you can see b is bigger than a. B is greater than a. Right? B square is 8, a square is 4, b is greater than a, which means what? This time for the eccentricity, we need to use the formula a square equal b square 1 minus e square. Can you see? So a square is 4, b square is 8, 1 minus e square is what we are trying to find, right? So 4 over 8 equal 1 minus e square. So I get here e square equal 1 minus 4 over 8 is half. E square 1 minus half is half. E equals root of 1 over 2. Root of 1 over 2 is root 2 over 2 or 1 over root 2. Everything is the same. Okay, so this is it. It's quite simple, right? So you now know how to find the eccentricity in the simplest way, right? Okay, let's quickly discuss the third question also. Question number 3. Look, an ellipse with equation x square over a square and y square over b square equal 1 has focus 3 comma 0 and the equation of the directrix is x equal 12. Explain why a is greater than b. So why do you think a is greater than b? Now they haven't told you a b values. They haven't, right? You can see in the equation a b values are not given. They have just given you the focus is 3 0 and the directrix is x equal 12. So why is A greater than B? Yeah, why is major axis on?
Focus are both in the x-axis.
Because your focus, can you see? Focus 3 0 means what? Focus is on x-axis or y-axis. 3 comma 0 means it's on x-axis. Directrix x equal to L is on what axis? X-axis. So you can see that is the reason exactly. The focus and the directrix are on the foci and directrix are on the x-axis. Therefore, A is greater than B. Do you understand? Write down the foci on the x-axis. Therefore, A greater than B. Next one, part B, Roman number 1. Find the eccentricity of the ellipse. So how do we find the eccentricity of this ellipse? So we know foci is what? AE, right? Foci is AE. So this they have told us the focus is 3 comma 6. So AE is 3. And the other one? Directrix is 12. So directrix, what's the equation? A over E is 12. So it's a what? Pair of simultaneous equations. A equals 12E. Let's substitute here. 12E into E equals 3. So 12E square equals 3. E square equals 3 over 12 is 1 over 4. E is half. No, we don't need the plus or minus here. We know clearly E is between 0 and 1. So E should be the positive figure, right? Part 2, the values of A and B. Get the values of A and B. So if E equal half, and right here A is like 12E. And replacing the E with half, I get A equals how much? 6. And how do we get the B value? So we use the equation what? A square equal B square, B square equal A square. A is greater than B, which means B square equal A square 1 minus E square. You must use this equation. Okay? I mean, clearly have an idea who is the major axis before you use this. You can't just use the equation as you want. You must have a clear idea who is your major axis. So B square equals, this is what we are trying to find. A square is 6 square or 36. B square is 404. How much is B square? 36 into 1 minus 104, which means 36 into 3 over 4. 27, which means 27. 3 root 3. So that also you get plus or minus. So what we'll just, we take the size of it. Is 3 root 3. Okay, then sketch the ellipse showing the directions on any points of intersection with the coordinate axis. Can't you sketch the ellipse now? So ellipse equation, first we'll write the Cartesian equation x square over a square plus y square over b square. Can you see the difference between the ellipse and the hyperbola is, the only difference is in the middle, right? The plus mark. In the hyperbola it was a minus. In the ellipse it's a plus sign. X square over a square plus y square over b square equals 1. So in the ellipse, the x-axis cutting points are 6 minus 6. The y-axis cutting points are 3 root 3 and minus 3 root 3. Okay, so so that's it, right? They want us to mark, hence sketch also, hence sketch the ellipse showing the directrices and any point of intersection. So they ask you to show the directrices as well, right? So what was the directrix? X equal 12, right? And the other directrix is at x equal minus 12, right? Right, and then your focus was at, what was the focus? S and S dash?
3, 0.
Focus was, yeah, 3, 0. Okay, so this is the equation of the directrices and the focus. So this is the ellipse. Is that okay? So now we are back to the hyperbolas, and we are going to now again, we are going to find the eccentricity equation, the equation relating A, B, and E in a hyperbola. So first so this is an example that's really important. Let's discuss it. So now they say here, show that for E greater than 1. Okay, the hyperbola with 4c plus or minus a comma 0 and directrices x equal plus or minus a over e has the equation x square over a square minus y square over b square equal 1. You know, eccentricity equation for hyperbola in the middle, it's a negative sign, right? Okay, so now your task is what? You need to prove that with these 4c and with these directrices, you end up getting this equation. Okay, so you need to prove. Okay, so let's get started. So you can see here, now here your e values are bigger than 1, right? So when you consider the value AE and A over E, who is larger now? AE is bigger than 1. So if E is 2, like you can see here, AE means it's like A into 2. So it's 2A. Like here, A over E is A over 2. So it's like halfway. Do you see here that when E values are bigger than 1, AE is going to be bigger than A over E? Input a value inside your head. Input a value for E. Say E is 3. So this is then becoming 3A. While this one is A over 3. So 1 over 3A is much smaller than 3A. Do you get it? So for E value is greater than 1, always your AE is smaller. A over E is smaller, AE is larger. So which means what? In this situation, your directrix is the first. 4C comes after. The focus comes after the directrix. So you see, because A over E is larger, it's larger. So now we are talking about the hyperbola. So this they have taken this P point P on your hyperbola. So I think you need to realize, I told you the directrix is always outside the shape, right? While the 4C is inside. So now you know hyperbola goes like this, right? This was how the hyperbola went. So can you imagine how this goes? So this is probably how it goes. Can you see? Because the directrix has to be outside of the focus, outside of the shape. The focus has to be inside the shape. Can you see how the hyperbola goes? The other one will go from the other side. Do you understand? Okay, so now what you need to do is you have to do the exact same thing that we did earlier. What is it? You must do the proof of PS over PM. So here P is the point on the hyperbola. So S is the distance to the focus and PM. Okay, it's the directrix. So shall we write down the equation? PS distance. So let's get PS now. Let's write the equation PS square. So using Pythagoras theorem, right, is equal to what? X minus AE square plus Y minus 0 square. Do you agree? Because you need to clearly identify that your shape is like going in front like this. Okay. So the x is in front, x minus AE square plus y minus 0 square. Whole thing, yeah, the square of it is equal to PS square. And the other one is PM. So PM is what distance? I think you can see PM is a direct horizontal distance. So directly, if I subtract the 2x values, I get the distance, which is what? X minus A over E. Okay, so I'll make it PM square, which gives me x minus A over E whole thing square. which gives me here, let me make it ex. I will make the common denominator so that it reduces the pain to us. I took the common denominator. Can you see? Can you see? Okay, now it's time to input into our eccentricity equation. What is the eccentricity equation? Eccentricity is defined as E equals PS over PM. Eccentricity equation is defined as E equals PS over PM. So E is, okay, E is gonna be here. Okay, we're gonna actually what? Square the whole thing, right? First thing is we'll square this whole thing. E square equal PS square is X minus AE square plus Y minus A square. Shall I take the PM square to the other side? PM square is this is okay. I took the PM square to the other side. What did I do wrong? Y minus 0 square. Yeah. This is Y minus 0 square. Just Y square. So EX minus A whole thing square over E square into E square. Equal X minus A E square plus Y square. E square to E square cancels, right? Let's open the bracket. E square X square minus 2AEX plus A square. Equal here we get X square minus 2AEX plus A square E square, and then plus you have Y square. Is that okay? I think you can see it. Similar terms cancel off. Minus 2AEX and minus 2AEX cancels. Okay, so now you have to clearly decide where do you take people to? Where do we take people to? So the original equation you're supposed to prove is X square over A square minus Y square over B square equals 1, right? Because now the thing is you have a decision to make. Are you going to bring this X term here, or are you going to bring this X term and the Y term to the other side? So which one is correct? Should I bring this E square X square term to this side? Or do I bring the X square and the Y square to the other side? Y needs to be negative. So I need to take the Y this side, which means along with it, this X square also will go to the other side. Understood? So it's the negative in the Y square we need to focus on here. So I'll take the plus A square here, the X square will have to come here and the Y square also should come here. Yeah, but still there's another X square here. X doesn't become negative because there is another X square part over here. So I end up getting here E square X square minus X square, and then I have minus Y square equals A square E square minus A square. Do you agree? When I take X square out, I get here E square minus 1 minus Y square. When I take A square out here, I get E square minus 1. Do you see some kind of a rearrangement here now? The sum or now? So you can see I kind of like have the equation X square over A square minus Y square B square equal 1. I have almost got it. The only thing I need to get rid of is to make the answer equal to 1. So let's divide the whole thing by A square square minus 1 is square minus 1. This also fully cancels, right? And you get a 1 here. So X square over A square minus Y square over A square E square minus 1. Okay? E square minus 1, right? Yeah. So now this is the equation, right? It's supposed to be X square over A square minus Y square over B square equals 1. So now do you see we got the eccentricity equation? So according to this equation, this eccentricity equation, what is the B square value? B square is equal to A square E square minus 1. Yes, make sure you check the difference between the earlier one and this one. There is a major difference, right? No, I mean, like basically B square was there when X axis was the major axis. It was 1 minus e square for the ellipse. So for this one, it became e square minus 1. The reason is because in this case, e is bigger than 1. So e value is higher. So in the other one, it was 1 minus e square because e was less than 1. So when you took 1 minus e square, it didn't give you a negative in the earlier case. But in this case, e is bigger than 1. So we got the answer is e square minus 1. So do you see? So in here, we don't have any issues about the major axis switching. The hyperbola coming to the other side, that doesn't happen. We only have the hyperbola on the x-axis. Okay? Is that okay? So we only have one equation, and you can check in your formula book. All the equations, including the directrices and force are given. Okay, so then after you get this proof, now what you need to do is write down all the equations. So this is it. Can you see the full summary? So this is the full summary. Write down the full summary. So this is the full summary that you need. For a hyperbola with equation x square over a square minus y square over b square equal 1, the eccentricity where e is greater than 1 is given by b square equal a square, e square minus 1. The 4c, can you see the 4c? Can you see they are inside the hyperbola? The 4c are plus or minus ae, and the directrices, do you see it's outside the 4c? Directrices are plus or minus a over e. Okay, so this is the equation. Draw this diagram and make sure you understand all the directrices and force because that's what you need to do. Next thing you need to do is to draw the hyperbola and the ellipse along with its force and the directrices. Okay. So in the next question number 5, the eccentricities of the following hyperbolas, they're asking you to find. So in these hyperbola questions, you don't need to worry whether A is greater than B or B is greater than A. Okay, because you only have one drawing for the hyperbola as I mentioned earlier, right? Okay, so it doesn't matter which one is greater because basically in the hyperbola will never cut the y-axis because when your axis is 0, you remember in the first part I did, you get y answers are, you don't get real answers for y when x is 0. Basically, this graph never cuts the y-axis. So regardless whether b greater than a or I greater than b, the hyperbola always has only one particular shape to go. Okay. So in part C, we have a square is 9, b square is 16, right? So I just want the AB values. A is 3, b is 4. Agreed? And what's the eccentricity equation? B square equal a square e square minus 1, which means for hyperbola, you only have one eccentricity equation. Isn't it? You only have one equation, just use that. So b square is 16, a square is 9, e square minus 1. 16 over 9 plus 1 equal e square. If I write directly, do you understand? So this is 25 over 9 equal e square, which means e is root 25 9, which is 5 over 3. Is that okay? E is 5 over 3. Next one, part C. X square over 4 minus y square over 5 equals 1. So here we have a square is 4 and b square is 9. Sorry, b square is 5. And you see a square is 4, b square is 5. So let's use the eccentricity equation. B square equal a square, e square minus 1. So b square equal 5, a square is 4, e square minus 1. So 5 over 4 equal e square minus 1. Is that okay? 5 over 4 plus 1 is e square, which gives me what? 9 over 4 equal e square. So e is 3 over 2. Is that clear? Yes. Okay, so this is the, yeah, and then that's it. And then, yeah, they want you in the sixth question, showing clearly the questions of their force and directrices. Okay, so get the force and then you have to sketch it. So let's sketch this. So when you sketch this, the force was at the force was plus or minus AE comma 0, right? Yeah. So plus or minus A was A square is 4, A is 2, right? E is 3 over 2. Plus or minus 3 comma 0. Is that okay? And the directrices x X equal plus or minus A over E. Is that okay? X equal plus or minus A over E. So directrix A is 2 over E is 3 over 2. Is that correct? So X is plus or minus 4 over 3. They want you to sketch it. So get the sketch as well. Get the sketch as well. When you draw the sketch, you must clearly, they have told to clearly mark the foci and the directrices. So then this is your sketch. Okay. Okay, yeah, the curve cuts at plus or minus A. So minus 2 and plus 2. And the foci is at plus or minus 3 comma 0. This is S. S dash is at minus 3. And then directrix. There are two directrices, right? Can you see? So first directrix is at x equal 4 over 3. The other one is at x equal minus 4 over 3. These are the two directrices. Can you see? So this is the ellipse, and basically where they haven't asked us to mark the asymptotes. But you remember in the hyperbola there are also what two asymptotes. Y equal plus or minus b over ax. Okay, so those are also there. They haven't asked us the asymptotes yet. But they had asked us to draw the foci and the directrices only. So if they wanted the asymptotes, then you would need to mark the asymptotes here as well. Is that clear? Okay.